Okay, we're working on this problem. We got all the calculus down. Now we're doing the algebra of solving for that dy dx. And so I'm going to clear my parentheses. And so I've got some distributing to do. I'm going to take that entire secant xy tangent xy times both those terms in the parentheses. So I'm going to have x cosine y dy dx plus sine y equals, and I'm going to drop down because I know I'm going to run out of room here. So I'm going to say that this is x secant xy tangent xy dy dx. So I took this guy, dx dy dx times all that. It's just all multiplication. I put the x in front, the dy dx on the end. Then taking the secant xy tangent xy times the y, that's just going to be y secant xy tangent xy. And so there I cleared my parentheses. First time, secant xy tangent xy times x dy dx. I put my x first, then my secant tangent, then my dy dx, and then times my y secant xy tangent xy. And then I still have e to the 2y dy dx. So I cleared my parentheses. Get terms with dy dx on one side, all other terms on opposite side. It doesn't matter which side you put things on. I'm just going to go to the left because I think it looks prettier there, but it doesn't matter. So getting my dy dx terms on one side. So it can be x cosine y dy dx minus x secant xy tangent xy dy dx minus 2 e to the 2y dy dx. So there was a dy dx term. I kept it on the left. Then there was a dy dx term, and there was a dy dx term. I subtracted them to the other side. I've run out of room. So equals. Okay, there was a sine y that was on the right, or on the left. Move it to the right, so minus sine y. That we moved, and that guy we still have. So plus y secant xy tangent xy. So all the dy dx terms on one side, all the non-dy dx terms on the other side. Factor out dy dx. And so I'm going to have x cosine y minus x secant xy tangent xy minus 2 e to the 2y dy dx. I'm going to drop down because I'm running out of room. Equals negative sine y plus y secant xy tangent xy. And lastly, divide. So I'm going to have dy dx equals negative sine y plus y secant xy tangent xy divided by x cosine x minus x secant xy tangent xy minus 2 e to the 2y. And there's my implicit derivative. Now, yeah, that's harder than what I would put on a test or quiz, but we should do the hard stuff in class so that when you get to the test or quizzes don't seem too bad. But it's a very algorithmic process. You do your calculus, and then you solve for dy dx. And one of the things that helps the most is just to be very careful as you write the stuff down. Okay, next problem. Again, dy dx, and we'll emphasize again, this is an equation. not a function. So use implicit. And like I said, on a test or quiz, I'm probably not going to tell you to use implicit. The homework does tell you. And if I was in charge of the homework system, I would change that. But on a test or quiz, I'm not going to tell you. You've got to recognize. So again, all the basic rules, but every time I differentiate a y, I follow it by dy dx. So it starts off easy, 3y squared. But I just differentiated a y, so I follow it by dy dx. Quotient rule. Plain denominator. Derivative of the numerator minus plain numerator. Derivative of the denominator all over the plain denominator squared. Now you certainly don't have to show that step, but it is a quotient rule problem, so that's where I started. Now doing those actual derivatives in there, derivative of x is 1, the derivative of 2y would be 2, but I just differentiated a y, so dy dx. Minus x plus 2y, derivative of x would be 1, derivative of 1 would be 0. And now all over x plus 1 quantity squared. And there we've done the calculus step. So now we have to solve for dy dx. And what I'm going to suggest first here is to clear the fraction. And I'm going to do that by multiplying both sides by that x plus 1 quantity squared. So over here, x plus 1 quantity squared. Over here, x plus 1 quantity squared, which then those guys cancel, which is the point. And so I get 3y squared, x plus 1 quantity squared, dy dx, equals x plus 1 times 1 plus 2 dy dx minus, and notice times 1 is not going to change anything, so I can get rid of the times 1 and then distributing that minus sign, minus x minus 2y. Next, I'm going to clear my parentheses here. I don't care about these parentheses here. I need to clear these guys in here so I can free up this dy dx. Eventually, I want all my dy dx terms on one side. I'm not going to be able to move this dy dx term around while it's still within all these parentheses within that multiplication. So I'm going to clear them there by foiling. And so I'm going to have 3y squared, x plus 1 quantity squared, dy dx, equals x plus 2x dy dx plus 1 plus 2 dy dx minus x minus 2y. X, 2x dy dx, 1. Yep, that looks good. Keep going. Get terms with dy dx on one side, all other terms on opposite side. And like I said before, it doesn't matter which gets which. I just like my dy dx terms on the left. So 3y squared, x plus 1 quantity squared, dy dx, minus 2x, dy dx, minus 2 dy dx equals x plus 1 minus x minus 2y. There was dy dx. I kept it, moved that, so negative 2 dy dx, plus 2, moved it, negative 2, dy dx. So I had 1, or at x, 1, negative x, and 2. Those guys clearly cancel. Factor out dy dx. So I'm going to get 3y squared, x plus 1 quantity squared, minus 2x minus 2, dy dx equals 1 minus 2y. And lastly, divide. And so dy dx is 1 minus 2y divided by 3y squared, x plus 1 quantity squared, minus 2x minus 2. Nothing cancel here. There's my final answer. If you wanted to multiply all this stuff out, you could. If you wanted to, there's no need to. The hardest thing most students have with this is the algebra. Be really, really careful with your algebra and try, be careful with your handwriting and just work through these step by step by step. Okay, we'll end that video at that point.